is this LMS. Hello, everyone. I was talking and I just started to record. This is Monday class, 11 a.m. class. I was talking about the LMS registration. LMS registration is important because, first of all, our rector's office wants it to be, you have to be seen in LMS. It's a formal area that you're going to be seen that you registered for the classes. And what's the benefit of the LMS is you can find all the documents on LMS. Anything that we do, I'm going to put in there. Videos, lecture notes, books, etc. Whatever we have, right? Not the books, but the book, anything related to book, like how to register, how to get the book, etc. So LMS is good and register there, okay? And I opened it up last night, okay? So you can register there. Number two, teams on Teams. So I formed a team on Teams, Math 101-1, fall 2020, I guess. Please register there, and I send the link through email. And find your section and register there, okay? And then I'm going to approve it. And from now on, we are going to have the virtual class online there, okay? And the third one is this link that we are on right now. This was the series of raise this series because the series is causing kind of problems such as you need to approve my invitation or decline my invitation, and lots of emailing going on, which is not good for you and for myself. Okay, so I hope this is clear. Do you have any questions about this explanation? Okay, some students are asking about the link, so I'm going to give them the link of this for now, and then we are going to next class probably we are going to be on our real team. Okay, just give me 1 sec. Okay. I sent the link to the group, actually the team that we have. So I think they can just find it even if they are checking the other team, okay? Now what I'm gonna do, I am going to upload and do some math, and we are going to take a break, and during the break we will try the other link, okay? All together. All right, so let me upload this. Let's see. Okay. 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 So are you seeing my screen? Can you confirm, please?
Yes, teacher.
Thank you very much. Appreciate it. That's good enough. Now, last time we talked about sin x, shifting sin x up and down to the right and to the left. And we are going to be talking about this exponential functions. These are also nice functions that we are going to use a lot, okay? What are these exponential functions? Look at this picture and make sure that your eyes gets familiar with this picture, these two pictures. I want you to look at the left picture, okay, the picture on the left, okay? The picture on the left, I'm gonna write some comments on here, all right? Okay. Okay, what do you see here? Let's see, okay? Here, the picture on the left, okay, first of all, what are exponential functions? Exponential functions are in this form. Look, let me make it bigger, just a sec. Okay, let's make it 24. Okay, y is equal to a to the x. Okay, let's wait. Why doesn't it write? Let's see. Y. Okay, y is equal to a to the x. Okay, this is called an exponential function. A is not 0. A is not 0. 0. Okay, a is positive actually. A is greater than 0. Okay. Okay, so this is called an exponential function. Okay, what's special about this? All right, can you hear my voice? Is my voice good?
Yeah, yes, your voice is clear.
Okay, perfect. Okay, exponential function. Now, what you have to be focusing on here is whether a is, we know, is strictly greater than 0, right? A is strictly greater than 0. But we have to be careful when a is greater than 1. Okay, greater than 1. Okay, or a is between 0 and 1. Let me write this a little bit nicer. So what is important for us is a being less than a is being less than 0 and 1, okay? And a is bigger than 1. So two situations. Situation 1, this is number 1. Okay, when a is between 0 and 1, the pictures are going to look like the one on the right. The one on the right, okay? Whenever a is, okay, graphs are looking like the ones on the right. The ones on the right, okay? Okay, do you find any names for this? Anybody can be creative and find a name for such graphs? Anybody can create a name? Okay, whenever a is bigger than 1, graphs are looking like the ones on the left. Okay, so it's going to be either this or that, nothing else. Okay, ones on the left. Okay, why? Okay, depending on the value of a if a is very small, between 0 and 1, the function is going to be decreasing. So I'm going to write that whenever a is between 0 and 1, the graph is decreasing. Okay, the graph or the function is decreasing. It's going down. Okay, graph. Okay. When a is bigger than 1, okay, bigger than 1, the graph is increasing. Okay, as you will see in the picture on the left. All right, increasing. Okay, look at that. It is going up. Do you see my cursor? I'm not sure. Do you see my cursor? Can you guys see my cursor?
Yes.
Okay, wonderful. See, this is going up. This is going up. Yeah. For example, A is 10 here. A is 3 here. A is 2 here. So the base, we call it the base. Okay, base. Let me write that. A is called a base. Okay, let me write that because it's a terminology. Okay, A is called a base. A is called a base. Okay, it's the base, taban. Okay, in Turkish, it is called a base. And if A is bigger than 1, it's going up like this. But if A is less than 1 and bigger than 0, the function is going down like this. Okay, it is decreasing. Okay, do you see this? Look, you can get confused here. Look at this 10 to the negative. Let me give you some examples. And let me explain this, okay? You can ask here, oh, teacher, the base is 10 here. No, the base is not 10. The base is 1 over 10 there, okay? Let me give you examples, okay? Example, all right? Example, y is equal to a to the, okay, negative 1. Let's see, a to the negative x. Not do that, okay. 10 to the negative x, okay? This is exactly the same function we have here, right? But you can say, oh, what's the base here? Okay, what's the base? Can anyone say what the base here? What's the base here? Is it 10 or 1 over 10?
It's 10.
In this example? In this example, it is not 10.
1 over
It is
10.
1 over 10.
You said
A. Okay, so this is very tricky. Look at that. Look at this one. Okay, this is power x. Do you see this now? Okay, do you see the one? Okay, maybe I should make it bigger. You cannot see it, right? Okay, let me make it bigger. Okay, sorry about that. Okay. Okay, so you can still hear me, right? Okay. All right. All right. Okay. Can you see my screen better now? Can you see my screen better now? Bigger, I made it bigger.
Yes.
Okay. If you want me to, I can enlarge the size of the letters, okay? If this is not good enough.
Teacher,
Go ahead. Okay, what's your
the
question?
problem is not in your letter size. The problem is your screen is stopping sometimes.
Oh, I see. But let me ask you a question. Did you experience this last week?
Actually, no, I didn't experience it last week, but your return connection was great last week.
Okay. Because we had some new internet coming up in our home, and there were some issues with my internet. So if you experienced that today, this is because of that, okay? Last week I didn't have that. We had some sort of renovation in the internet, but there was an issue we didn't foresee. So this could be the reason that you may not properly follow me, okay? That could be the only reason if you were following me better last week. Okay, I'll fix this ASAP. All right?
Okay, thank you, teacher.
Too bad? Is it too bad? Is it really bad?
It's not too bad. We can handle it, I think.
Okay, I want you to be patient, okay, today, and I will try to fix it. I have to purchase some new wires, etc., and have it fixed, okay? Okay, anyways, so I'm gonna continue now. We are recording, maybe in the recording you can see it better, okay? Example, yeah, we were talking about this example, and this is an exponential function. Look at the base. Okay, what is the base? A is the base, right? We call it base. Okay, base. Let me rewrite again so that you remember. So this base, is it less than 1? Yes, it is less than 1. A is 1 over 10 is less than 1. And is definitely is less than 1. Okay, therefore, what is the graph? The graph is going to be, graph is decreasing. Graph is decreasing because of that. Okay, decreasing. Okay, similarly, I can give you another example. I can give you another example here. I can give you another example. This time I'm going to make it, if you like, let's say 9. Okay, this is the same as 1/9. Okay, and a is equal to 1/9. 1/9, which is the base. 1/9 is less than 1. So the graph is decreasing. Let me give you an example where the graph is increasing. So I'm going to make it, let's give 2020. Okay, not minus. This is not minus anymore. This is 2020 x to the x, right? What is the base now? The base is 2020. 2020. Is it less than or bigger than 1? Of course, it is bigger than 1. It's bigger than 1. Is bigger than 1. So the graph is not decreasing anymore. It is increasing, right? It is increasing. Okay. So this is what we have with exponential functions. We are going to, okay, let me give you another example, okay? Example. I am going to make a little bit change. I'm going to do this. Look, 4 to the, okay, 4 to the x plus 6. Okay, let me erase this. Okay. Okay, so what is the base here? Okay, let me rewrite. The question is draw the graph. Draw the graph of this function. Okay. Okay, let's try to draw the graph of this. Okay, solution. Solution. So do you remember? Okay, let's do. So this is we are adding a number to x. If you are adding a number to x, is it shifting up or down or to the right or to the left? Which one?
To the right, I think.
Okay. Okay. Is this true? Can anyone say something else?
It's left.
That's right. That's right. Is the shifted graph of y is equal to of, all right, let me move this a little bit if I can, of y is equal to, okay, actually we are going to draw the graph of y is equal to 4 to the x, and we are going to shift this graph to the left by 4 units.
Teacher, but this is not a parabola. Why are we shifting it to the left?
Because we are changing x. You are changing x. If you're changing x, then whenever you change x, adding number, subtracting number, no matter what this function is, you are shifting to the right or left. If you are adding to y value, then it's shifting up or down. Let me show you, okay? I'm going to change this question to this. It doesn't have to be parabola, any function. This is a rule, okay? Okay, let's do this as follows. Look at that. Okay.
By 4 units or by 6 units?
Oh, 6 units, I'm sorry. By 6 units, yeah, I made, thanks for correction. Okay, okay, for x cubed, 4 to the x. Okay, plus, let's say 15. Okay, draw the graph of this function. The graph is a shifted graph of y is equal to 4 to the x, up, upwards by 15 units, because you're changing y now. Okay, you're shifting it up. Okay, if you say minus, it's shifting down. Okay, if it was minus, you're shifting the graph of this downwards by 15 units. Okay, all right, so anyway, so what you're gonna do, okay, this picture, so with the exponential functions, when you're shifting to the right or to the left, by 4 units or 6 units or whatever the units is, it would not show very clearly, because look, the graph is just like this. If you shift it to the right or to the left, it's gonna change just a little bit, okay? So the difference is not very obvious, but you should just mention it in your writing, okay? But if you shift it to up, for example, this up by, for example, 10 units, so this point is going to go up to here. 10 units means 12. It's going to be right here, okay? I mean, maybe a little bit less, somewhere here. So shifting up and down is okay, but shifting to the right and to the left is just going to be difficult to observe as much, okay? Especially for the students who are seeing this for the first time, okay? So be aware of that. Okay, these are exponential functions, and we have logarithmic functions. Let me continue with the logarithmic functions. For the logarithmic functions, let's write a couple of things. Let's write them here. Okay. I'm gonna move down here. Okay, I'm back with you. Here, I is equal to, this time we have logarithm and the base. We have logarithm a. This is the base, by the way. Okay, x. Okay, I'm gonna make the, not capital like that. Okay, a is the base. Here, a is the base of the logarithm, is the base of the logarithm. Okay. There's a relationship between the exponential functions. So this logarithmic functions are going to be, you can consider, they are very much related to exponential functions in the way that actually this expression is the same as, okay, let me write that here. Okay, sorry, is the same as, all right, what, it's the same as x is equal to a to the y, a to the y. Okay, these are just the same things. Okay, let me write it like that. Y is equal to, this is a note. Let me write this note. Okay, y is equal to a to the x is the same as x is equal to a to the y. So there's a relationship between logarithmic functions and exponential functions. And look at the base here. Functions, the base can be 3, 2, 5, 10. It could be, okay. And they are going to be all going through 1. All right. Why is that? Because whenever y is equal to 0, x is 1, right? 10 to the 0. Yeah. Okay. They all go through the 1. Okay. Let's write that. This is the first node. And then second node is that. Okay. They all go through. They all go through the origin. Okay, origin mean, I mean not origin, sorry. They go through the point through x is equal to 1. I'm sorry, through x is equal to 1. Why is that? Because of this definition in note 1, right? Because in order for this to be x, y has to be 0, right? Okay, so this is the y-intercept. How would you find x-intercept? How would you find x-intercept? Okay. Do you guys remember x-intercept? I told you y-intercept before, but I didn't tell you x-intercept. Can anyone tell me what x-intercept may mean? Okay, does anyone know? Let me write that. Does anyone know? No. X-intercept, what does it mean? Can anyone say? Or what is the x-intercept in the graph here? Can anyone say? What's the x-intercept here in the graph?
Can it be 1?
That's right. X-intercept is the point where our graph passes through the x-axis, okay, x-intercept. And y-intercept is the point where our graph passes through the y-axis. Now, do you see any y-intercepts here? Okay.
No.
Okay. No y-intercepts, because the graph never ever hits the y-axis. Okay, no y-intercept, but it has x-intercept and x-intercept. Okay, this is answered. My question is answered. What the x-intercept is, right? Let me give you the x-intercept definition here. X-intercept is the point where, okay, where the graph intersects the x-axis, okay? Okay, similarly, y-intercept is the point, okay, let's write that too, okay? Y-intercept is the point where the graph intersects the y-axis. And in this example, in logarithmic functions, in the example here in the graph, in the examples, in the picture here, okay, x is equal to 1 is an x-intercept. On the other hand, there are no y-intercepts. On the other hand, okay, and there are no y-intercepts because it never ever intersects here. But it doesn't mean, okay, it doesn't mean logarithmic functions will never have y-intercept. Can you imagine a situation where logarithmic function is going to have a y-intercept? Can you just create a situation where it's going to have a y-intercept? Can you tell me? If you do what, then it's going to have a y-intercept. Any suggestions?
Shifting left.
That's right. If you shift the logarithmic function to the left by 5 units maybe, or 10 units, whatever, and then it's going to definitely have a y-intercept. So, okay, that's very good answer. All right, so I want you to see one more thing as well. Another note here, I'm going to write another note. Okay, note. Okay, number 2, number 3. Okay. Number 3, I told you that there's a relationship between exponential functions and logarithmic functions, right? Actually, these two functions are inverses of each other. So log and exponential functions are inverses of each other. How do I know that? Actually, inverse functions are the ones where their graphs are symmetric with respect to the y is equal to x-axis. Now, imagine that we have the exponential function with the a positive. It's going to go up like this, right? Going up like this, and it's going to go through 1. So actually, if you draw a y is equal to x line here, so exponential function and logarithmic function are symmetric with respect to that line. Okay, and this is a proof that these two guys are inverses of each other. Whenever you have two functions that are inverses of each other, their graphs are symmetric with respect to the y is equal to x-axis. Okay, okay, and let me explain it here. Just write it in here. Y, okay, y. The graphs of each, okay, are symmetric with respect to the line y is equal to x. Okay, they are symmetric. It's like a mirror image. Okay. Example. Okay. Y is equal to 2 to the x. I mean 2 to the x. Okay, one more time. To x, and okay, y is equal to, okay, logarithm Okay, what's going to be the base? Base is going to be 2. 2x. This x, not 2 times x, it's just 2 and x are inverses of each other. Inverses of each other. Okay? You can draw the graphs of these. At home, when you get home, you draw the graph of y is equal to 2x and y is equal to logarithm 2 times x, and then see their graphs are symmetric with respect to the y is equal to x line. Okay? Let me see if I have the access to graphing tool here, and then we can ask it to draw. How many minutes? We have 50. Yeah. What I want to do is let's see. I'm gonna stop here, and then I'm gonna draw on an online graphing tool, and then we are gonna continue from there our next class. But when I'm doing that, when I'm trying to find the graphing tool online, we are gonna be on the break, all right? And then I'm going to ask you to try to meet me on the teams that we created, okay? That you registered, okay? And let's see how many students we are going to be able to meet me over there, okay? Just, I think we can, let's see, we have to just turn this down maybe. We have to log out of this account and then try to meet on Teams on the other side, okay? On the other Teams group. Is this clear to you? Can you do that? Can you manage that? Let's give it a try. If it doesn't work, we can come back to here, okay? Just practice that. All right? Okay. So, where's my Teams? Okay, just a sec. Why don't I see that? Yeah, I don't want to cancel this too. Just a sec. I want to go to the Teams here. Okay. Okay, if this is understood by everyone, let me take the attendance first here, because if I close it, I may not take the attendance. Let me take the attendance here now. I'm going to take it through a file as well. Okay. Just a sec. First class attendance. Okay, first class. Okay, I did that. Let's put it in here. Okay. Okay. So you heard me, right? We are on 10 minutes break now. I'm going to continue in 10 minutes, but let's go to the other teams, and I'm going to make it available and hang up here and see if we can all make it work, okay? Okay, let's see. Is there anyone, by the way, is there anyone who has not registered 101 team here? Is there anyone? If you haven't, then we may need to send you the link to register again. Can you confirm if there's anyone who has not registered to the team yet? Okay, I don't hear anyone. So that would mean that everybody is good. So let me stop recording here. Okay,